And we're live in 3, 2, 1, go. Hi, my name is Alex Shalaev, and you're watching Testcontainers Live. It's a great show where we talk about the different components and different projects in the larger Java and testing ecosystems. And today we're going to talk about a very inspiring project, a database. We're going to talk about the graph database Neo4j. And in our virtual studio, we have our guest, Gerrit Meier. Gerrit, how are you doing?
Hi, nice to meet you, Oleg. Fine, I'm great. Hi, for the rest of you out there in the internet, I'm Gerrit, working as a software engineer at Neo4j, primarily working on Spring Data Neo4j. So we just continue this spring journey, I would say, that just started last week. I'm looking forward for the next hour.
Yeah,
And
I
there's
think it's going to be excellent.
already a spoiler somewhere hidden.
Oh yeah. We also have Kevin. Kevin, how are you doing? Last time I think you were in Turkey when you joined the stream. Are you back
Oh
home?
yeah, indeed. There I joined from Istanbul. Oh no, one time I also was back here in Germany. And yes, I mostly joined because I'm so interested in the domain we are going to explore today. I'm already excited about this very much. So let's see.
Excellent. Before we start going into the actual demos and start hacking, maybe we can introduce some concepts a little bit. So Gerrit, can you maybe say a few words about what Neo4j is? How, like, I saw some very inspiring tweets about how Neo4j grew so much in the last year, and it is very, very interesting. So
yeah, that's correct. So I'm part of the journey since 4.5 years now. So I founded the Spring Data Neo4j and Java object mapping team in general. We are now two, Michael Siemens and me. I think he will already be commenting in the stream, so he can introduce himself. Yeah, but since then, Neo were already a few years old, so a decade or something. The idea of graph database, as it's in the name, is that it's not storing tabular data like relational database do, or documents that are more likely not very strictly connected, but to store data in a graph, like you can see in the background. That means that we focus on nodes and vertices and edges, nodes and relationships, how we call them. So the idea is to have really good performance in a graph database for a new query through your relationships, etc. And then are very popular use cases. You might heard of the Panama Papers, Paradise Papers, where we have this intense journalism. So people really dig into data. And the key point and one takeaway that we just scratch the surface on today is that a graph database, in contrast, for me, as my personal opinion, to other data stores, is that you put data into the database, but you ask the questions later. The questions arise through the data. You want to get answers. And that's not the typical use case we have when we use, for example, Spring Data Neo4j only when you store the data that you want to read. But we have a very broad field for you with graph analytics, so you can apply your possible knowledge from your university to graph databases. I failed the exam 2 times. So yeah, but yeah. So this is great for exploring data and to get answers to maybe questions that you did not had when you put the data in the graph. And since we all generating tons of data today, and this data is not only one disconnected dot, but it has all these relationships. You can really explore deep into those graphs that the persons by nature create when they have relationships.
Yeah. It also works very well for exploring blockchain transactions, by the way, and finding suspicious cycles in transaction graphs there.
Yeah, so Kevin and me did a live stream on this.
Right. Maybe we can explore topics like blockchain at some later stage. So coming back to Neo4j, graph database. I know there are different types of graphs, not different types, but different kind of sort of properties that graphs do, and some tools might be better for certain ones. Would you so Neo4j is the general purpose graph database? Does it perform better, or like are there any special qualifications to that? Like would you work with sparse graphs, or like giant graphs, online graphs, offline graphs, or does Neo4j does it all?
So I would say in general, Neo4j would do it all, but you really have to focus on the strengths the database gives you. I think that's very, very common. So when we talk about Neo4j, we talk about a label property graph. So we really focus on multi-labels, on edges, etc., and not properties. Oh no, you got me on the wrong foot. The other type of graph databases. But it's very the thing is what I focus on most when I use graph databases, that I really want to have fast hops through the relationships. So what's typically a join and can get massive amount of data and cross products in your output in a relational database, for example, is more or less simple pointer chasing in the model how Neo4j stores the data. So this is a big strange. And yes, what we are playing with today, and I really say playing, is only, I think, 15,000 nodes. Now Neo4j is really for millions of nodes relationships and be performant. Yeah, we had a demoing use case where we scaled Neo4j at the last Graph Connect keynote. Yes, and we like to process data and yeah.
What's the largest database that you've touched, like, and run queries against?
I didn't do such things. Yeah, but yes, we have
but
billions,
like in your
billions
experience,
of nodes. I've heard
millions
of
of nodes.
in my experience, it's just maybe millions. But it's more this negative feedback I sometimes get because I do Java object mapping. That means, okay, we somehow transfer a low memory representation in a database of some structured text and data types into Java objects. So we have, of course, a little bit of memory consumption when we do this. So people complain sometimes that they cannot really do this in one batch. That's when I get confronted with millions of data, because people just want to convert all their data at once at best. And they complain that it's not working. So yeah, that's where I see millions of data.
Millions of nodes is good. As a developer, like I wouldn't expect you to be like an operator of a very large data stores and data sets, because that's maybe an ops problem or an actual application. As a developer of the thing, you might not hit those use cases. Okay, but enough about that. Neo4j is a great graph database. I think if you haven't tried it yet, it's very easy to get started, and we can maybe show how to get started with Neo4j using it from a Spring application.
And yeah, sorry, Oleg, go ahead.
Yeah. No. I mean, like maybe we can show it, right?
Yes.
Just to inspire people and show how easy it is to integrate those great technologies together.
And yes, even if we do not show this today, you can get your very own instance by downloading Neo4j Desktop, full-fledged environment where you can manage multiple instances, or most low-level via Docker, or in between as a server application.
Or by the techniques we see today.
Yeah, because I just wanted to mention this because we don't have 2 hours, but only 1. So, of course, since you invited me, and I'm grateful that you did this, we will use test containers throughout the evening today.
That's
so
pretty good. I like that. I like that. I feel
Yeah.
that this should be a technology choice, even if we don't invite you.
Yes, and
But
it
like just for the technology reasons, because
and
it's excellent. But I appreciate the sentiment.
yes, it's up for the viewers to decide this, and it should be not my fault if it's not, because I try my best. I just got a few minutes training by Oleg and Kevin to do it even better. But yes, we are using test containers since years now in general, because we started our latest major update of SDN, SDN 6, with test containers upfront. So of course, you have seen this, Kevin have seen this as a byproduct. Michael committed the Neo4j support in test containers. Yeah. So we are really glad to have test containers. And yes, but it's new for me to really say, okay, we have a full presentation just with test containers. It's gonna be interesting. But
we're gonna help you in all.
Yes, we are
every
here
way
for
we
you.
can.
Yeah.
Let's try doing it. So what do we need now?
I
We need
said this to Kevin and Oleg, and sorry for this. I cannot read the comments, so if anybody does not get answers,
we're gonna forward the questions to you, and we're gonna handle the chat, so it's all good.
Yeah. Because first of all, let's give me an introduction to our domain for today. You've seen this already, but I don't know. Do I share my screen now?
Yes, it's
perfect. Your screen is on.
Crisp.
So crisp as the image could get. So my son were joining school last summer, and I think it's very pretty common at schools that you have this group forces that you have to buy this or wear this. I don't know, but now it was the time to Pokémon again. I, in my years, had no experience with Pokémon. I've seen some pictures, etc., but it was came just after I put the Game Boy to sleep, so I had no idea. So he came with his packages, with his booster packages back. So I know this because I know Magic, so I know what a booster is. And of course, it's stacked up at home. There were Christmas, this 25-year anniversary packages came out. Of course, yes. I don't know if you can see this, or it's getting keyed out. Yes, we got this all. And now he has hundreds of cards. I don't know. But
that is excellent. I think this is a very, very good parent-child like activity. So
yes, I do not show the private pictures. So we put them all into a database, into a Neo4j.
Right, excellent. So just to catch up the viewers who might not be familiar with the Pokémon, the card game.
Yeah,
there are cards like this. There are small cards. They have creatures on them which are Pokemon themed, like and those. Then you can gather them, you can collect them, or they have also a number of stats. There are different things that are Pokemon related, which are like Pokemon are those franchise of creatures, right? You should know them because of the Pokemon Go, right, which was worldwide 2016 phenomenon when we could go outside. And then it stopped being a worldwide phenomenon because we couldn't go outside anymore. So there are a number of stats. There are a number of relationships between things. There are different evolutions of the same creature. There are type. There are some, I don't know, attack modifiers. And you sort of make them compete with each other. So there are a number of stats. There are many cards like that for that people can collect. And today we're going to try to put them all in a database. And that would be our model, right? And then we're going to try to explore some relationship between the cards. You don't have to be a Pokemon fan. This is just the domain that we're going to explore. This is just the provider of the data for us. And we're going to try to concentrate on how Neo4j allows you to import and explore things, what tools are available for you to look at the data within the Neo4j database, and how you can connect your Spring application to to the Neo4j instance with data, and then how you query that, this and that. So the Pokémon things here are just the canvas on which we're gonna paint our application.
You can implement it for any trading card game like Magic the Gathering or Yu-Gi-Oh! Or what else out there.
The Pokemon card game is this particular interesting because you have multiple Pokemon cards of the same Pokemon, but there's only one. Let's keep it real. There's only one Pokemon of a type. So Pikachu there are plenty cards of Pikachu. So you have Flying Pikachu, you have this Pikachu, you have Surfing Pikachu, whatsoever. There are many more, but there's only one Pikachu. And as Oleg just hijacked my narrative, I just wanted to say the same. We do have all these connections. We don't have only the types and weaknesses you have seen maybe on the cards. Weaknesses, resistance, so it's a bony. But also a card belongs to a certain set of cards because Nintendo makes money. The Pokemon company makes money. So you have plenty of sets each year that belong to a series. A graph, of course, those things are connected. You have Pokemons of the same type, like here is electric. And then you have these evolutions, where you have a simple evolution like this. Remember this evolution because we try to find this later. So the first idea was, okay, we have just a few cards, just a few hundreds. So I do not want to enter them all manually. What a good developer does is looking for sources. And if you really want to be part of the party, I found this site. We can add this as a comment, I think, in the end on the stream. A Pokemon trade card game developer page. They are not affiliated with Pokemon and Nintendo, but it's more independent project. And we do not want to stress foreign APIs. And they are really good people, and they share the data with you. So you can get information about the sets and all cards that exist until today, as a static import. And that was the base of data I've used to create the database. So hopefully you have rewatched or were live attending Josh's stream last week, because I created already a Spring Boot application with dependencies to Spring Data Neo4j, what we will use later, and Testcontainers Neo4j. And I also imported the data we will use. So what I've shown you on GitHub is the very same data you can see here. We have our sets of cards. So I have nothing physical to show you for this. And we have all cards ordered for each file is one set by sets. So for example,
the first set came out in 99, it means, yeah? Because it says there in the file.
Yes.
And yeah, okay. I remember because I started with the first set. Very good.
Okay. Yeah, like I said, I never did this. So I have this primary school knowledge that I just added something when I explored the data around this, because I found some interesting informations when I imported the data that seemed to be wrong, but I've then saw how rules got changed, etc. Yeah, that's interesting, but I think that's too nerdy for today. But that's even something I did not expect to find there, and that was when I got interested into this. So I started with the whole idea around this topic, I think 3 months ago. Yeah. So
before we go further, can you please increase the font a little bit? I think it's
okay.
Yeah, just yeah.
It's already increased.
Yeah, good. Okay, good. Very good. Thank you.
It should stay. If not, please shout out again. So we have basic information about a set. So a set has a certain name, like base, or now we can see 2 sets here on screen in jungle, but they all belong to the very first series that has only the name base. So you can see the grouping. Then you have a certain amount of cards that get printed. We will see this later, that this is gonna be interesting. So the official number of cards that a set has. So different cards that are in a set. And yeah, some more meta information, like Kevin pointed out, the release date, etc. That should be all for sets. Cards have more information because they are different cards, like Pokémons that we have seen, or trainers that are, if you're into magic, like a sorcery or similar. You have more information, different information on those cards. But let's keep it simple as it is, and I'll take something common. And you could see that also there for Pokemon, we have a name, some health points, then the types that we have seen on the Pokemon official Pokemon page. So it's not usual, but Pokemon can have multiple types. And then we already have information about the evolutions. What we do not look at in this example are the attacks. So you could really model then, would this be a good Pokemon against a certain other type, defense and offense, and such things.
And we could find the optimal decks in, like the optimal deck compositions.
Yes.
It's like the optimal strategy in blackjack that these MIT researchers found in the 80s.
Yeah, maybe that's my chance to
some
shine
computer science,
game.
mathematical stuff in there.
Yeah, I have no street knowledge about Pokemon, so I need to cheat with a computer and with Neo4j. But let me continue. Some interesting things we need to just remind over the next minutes is, for example, the national Pokédex numbers. So Pokemon, as we have it here, we have the creator Pokemon or the type Pokemon of this card, has a national Pokédex number. So when we talk about you gonna catch them all, you will fill, your story is to fill your Pokédex. As it's like an index of Pokemons. They are 800 something. And now this is for us, for me, for my import, the pointer where I say later on, I want to find the Pokemon for those cards because I want to connect them also. So I have this few Pokemon, Pikachu cards, and I want to connect them to a really creature like Pokemon. So just to get the idea.
This is basically mapping the trading card domain back into the real world domain, like the Pokemon real world domain.
Yes. Of course, you will see this in the input statement. I think they are interesting to have at least a look or a glance, because you get some feeling how to do readable imports statements with Neo4j from a JSON file. I won't say that they're very performant. I don't do those imports daily. That's the reason why I just tried to bring my ideas down into Neo4j's Cypher statements. So Cypher is the query language that we use in Neo4j. But you get the idea. So I now have, I don't know, 14,000 cards to import with a few sets. And all these weaknesses, maybe the types, and the resistances. I also wanted to have those types extracted, because we cannot only put properties on our nodes but also on relationships. So I said I can have some kind of modifiers. You will see this in the imports. So I created a clean import script for me to get the data into the database. First of all, because I'm sure that I'm the only one who is using the database, and if there's any left data, corrupted data, I just want to get rid of all the data in the database. So we have a small query for this. I want to have a constraint for card IDs. Something where we have the set name followed by the ID, the number of this card in the set. So I really have a business identifier in this case. Oh, we can do a more serious talk about those things. Yeah. So we don't have play cards, something more serious in the domain. So we have business identifiers. Then some indexes, because I just want to have fast access when I connect the cards later on via the names. So I create them upfront to be sure that, of course, every creation of a node will take a little bit longer to add them to the index, the informations, but in the end, I have a better one. But the most interesting thing comes now. We are doing the imports. So for a set, this is pretty straightforward, but because I use them later to reference them for the cards and also show you the pattern I will do for the cards. But the card does more, and so we have a smaller view on this import statement now. For the import, we are using a Neo4j library called Epoch, or some procedures on Cypher that has the capabilities of loading JSON. Neo4j itself can only load CSV, but I did not want to convert data, etc. In the best case, I will remove these cards from my repository and do a submodule or something like this to have always current cards when I run the import. But that's another topic. But you can see I create the set from my sets. So this is JSON path, simple JSON path. You might have seen that I have a data array where I import the data from. So I create for every entry in this array a set. But a set can also mention a series that we have already seen. We have just when we had to look at the base sets, you have seen that we had jungle and base. Both were part of the base series. So in the first one, this merge statement will create a series with a name base. When we come back later for the second set, jungle, it will, via this merge statement, check if this exists and only create it if it exists. It exists. That's why we do this. It's like let's keep it simple. It's a shortcut where. It has more other capabilities, but it's a shortcut where. So we merge on the name. It exists, so it does not get created. But in both cases, we get the set and the series variable and can then create the relationship between both. I could have issued a create here. Yeah.
Right. And then we continue.
Lots of stuff happening with like just few lines. Yeah. So quite cool.
So we're creating 2 nodes each time, at least one additional one and one relationship.
Excellent.
And now things explode a little bit. I will speed up. No problem at all. But so you just get the idea.
Let me try maybe do this. We also create more. We parse again the JSON files, right? And we create new nodes, and then we explore the existing nodes, and then we add labels to the relationship for the types and everything else there, right? So that we just do a lot of matching and a lot of merging. So we sort of, in the layman terms, like how a very mediocre developer as myself would understand this, is we sort of create relationship to avoid doing joins later. And if you think in terms of a relationship database, right, you would have tables with data, and then every time you want to create a relationship, you join those tables based on some values. And here we sort of do that ahead of time, and then we create the relationship, and then we can query those very, very fast because we already have the edges in the graph created. So
yeah,
I think
that's an interesting view on this. Really,
No,
really
I'm afraid-
Interesting or correct?
It's correct one, but also interesting because we only say, okay, you have all these relationships already. You would do joins with SQL, but you only hop your relationship existing ones, and not this upfront idea. I think that's great, Oleg. That's really, really good. Yeah.
Oh,
And we do this pre-major, let's call it the pre-major optimization of our data fetching later. Also in a more complicated way, because the cards have more values, the cards have more relationships, more new relationships, but you can see the same pattern arise every time. So we have rarity. I just missed completely rarity. Of course, rarity. Rarity is something we want to check. Please let us have a look later in our console, in our browser, how this data looks like. I do not want to explain every part now because it will just take time.
Yes. I think we need to go a little bit ahead towards the testing and Spring stuff, because else we will run out of this.
Not so interesting like this nerdy domain right now.
Oh, it is not so interesting. I think it's also interesting.
I don't know. But here you can see the moment I jump from, I took the types, labels. For nodes, we call them labels. For relationship, we call them types. Everything with this colon up front. But you can only have one type on a relationship. And multiple types on a node. Is here where we do the jump from our card collection with 14,000 cards to the creators. I call them also Pokémon. Maybe there's a cross-cutting concern somewhere in the future. I don't know, but I wanted to be sure I have creators and cards. And now we take this Pokédex number, where we say we join, we really create them for every distinct Pokédex number I've seen. So that's the moment I just put some arbitrary additional nodes into my graph with some number.
Excellent.
And now, and that seems to be the worst cipher statement I've ever written. Also performance-wise.
Let's skip it then. Let's not show bad examples.
This adds the finds out the shortest name of card, but the common name. So we have Pikachu something else, and Pikachu, and it just takes the name Pikachu and puts on the creator. And then the most important step, now we extracted just some loose coupled Pokemons from the Pokemon cards. We want, of course, to have relationships to them. So I create here also by matching the shortest name of the creatures now on the cards, the Pokemon relationship. So now my Pikachu card, I just missed this. I do not have the Pikachu toy here. So my Pikachu cards get a real Pikachu. Yay! In this case, yeah. And what we are all here for, evolutions, because that's the only thing I knew up front that Pokemon can do. Pokemon can do this. So we also create from the original data from our JSON, where it says it evolves to, for example, Metapod. But this data is somehow mixed. So we also have evolves from, so we have to look at both directions in the import. But I just want to have a clean evolves to connection between the Pokemons. Yeah, and simple as it is, this unoptimized import just takes 40 seconds to run. But I promised, because it's easy to use, to go with test containers right from the start. And so that you don't have to wait too much. And you have seen this, I think, in every stream now. I created the Neo4j container already for you. That's also because I have only one display. I cannot cheat. And I do not want to see you to see me cheating.
Right. So just to give some context, this is a Spring application that you created using Start Spring IO. You added Neo4j data dependency, test containers, and sort of that's basically it, right?
Exactly.
And then This is the first thing that we're adding.
There's nothing in here. So you can see empty application. In the support, this is just here for parsing my import. I've shown you because ASCII doctor, and I just want to execute every cipher statement in there. So we have a somehow readable cipher here. All the code highlights are not working right now.
So we're starting with the tests, right? It's the test first approach. I like that very much.
And Spring Boot added in, now I have to like 2.4, the dynamic property sources. That's perfect to work with test containers because we can just say after the start of a test container, please give me your URL, your configured additional configurations like the passwords, etc. But also show me where you expose the ports, and I can pipe this into my application configuration. And this is exactly what we do here. Now I have to.
Right. Just to clarify, there is a Testcontainers Neo4j module, right? And you imported that as a dependency, and that's how you got the Neo4j container abstraction.
I can show you, of course, this.
Okay.
We're using the latest version. So we are overriding.
Yes.
Of course, we are overriding the defaults.
But latest and greatest
to have the test container support. I wouldn't even need Spring Boot right now or Spring application around this, but I love to use, of course, start Spring IO to get my application running because I want to add just Spring Data Neo4j because we want to fetch the data then in Spring Data fashion. And that's it. So what I did just to have this integration base that it prints me out like logging who does logging URL where my container is running with the Neo4j console connecting to the instance of test containers. So I was just verifying that I'm using local test containers, and then we do the import of our import file that we have seen up front. There's just some checking here that we do not want to run it on each creation because if the database is already populated with data, we do not want to issue the import again.
Oh, okay. So because the data is immutable, right? We have sort of a predefined set of things. Exactly. So when you initialize the schema, when you initialize your database, you quickly, you run a quick check to match whether there are like Pokémon, and then where there are, you don't initialize again because you know already that the database is created. Very good, cool.
Exactly.
That's
so this is the idea. I think everybody can benefit if they really want to test against the business data and they want to use test containers with this trick. So only execute the very expensive imports, time expensive, of course, and with resource in general expensive import only if you have to do this. So maybe you want to have it disrupt or a new fresh database, then you have to remove the data by hand with a previous statement or similar. Otherwise, I would always advise to use the reuse capabilities of test containers, because as long as the container lives on my machine, right now it's my machine, it will just import the data. And you can see this already. So I'm inheriting from this test class just to start one test. So I created one test that we have. If we would have more time, we would have seen. Oh no, I cannot do this right now because we don't have. So I just need to create some test.
Just the classic context loads, yeah?
Yeah. The classic context loads, it does more or less nothing.
It checks that Spring Boot starts up, which is pretty cool already.
Yeah.
And everything is assembled, yeah.
I think it's already running. Should run without anything. The other thing is the Spring Boot test that we, Spring Data test that we will do in a second. But I just want to force my testing setup to create the database upfront. So you have the init db call with the driver. And one nice thing about Spring Boot also is that if you have a driver, a Neo4j driver on your class path, you can get the pre-configured driver initialized. So it's looking at the, in general terms, application properties, be it dynamic property sources right now, or the real test application properties, or then application properties. For our test case, you will get a configured instance. So I can then use this driver to call initdb with the driver. So it just should now initialize my local test container instance.
So, but we just put this call now for fun in a test method, because normally we would not put it in a test method because it's like a before
it would
or
be
whatever.
A before each or something. The driver is now, and it is pretty fast because the thing is that I've already had a local instance running. But the nice trick now is that I've printed out this URL, is that I really have my container accessible on my system. So I could use already this database.
Can you, this is very cool, but can you catch up and help me understand this better a little bit, right?
Yes.
So you run the test, and the test passed, and the JVM is no longer running, right?
Yes.
And normally test containers library takes care of the life cycle of the containers, and then it cleans up after the test run by using various strategies, right? So the only way, like, how did you get the container running after this?
So the container is still accessible via the what's it called, wire engine. I think Kevin can. Sorry.
So it's still accessible over the map port, because, but so I saw it when you showed the tests why the container is still living. So if you open again the integration base class, so we glance a little bit above. If you go to the top, we see you created or configured the container with reuse, and this is like this alpha test containers feature. So it's not really completely solid, but many people start exploring it, and especially it's great for such explorative things where you want to explore the state of a container in a certain situation, or just want to do very incremental, very iterative development. And this reuse config is a very great feature, so to say, that helps you and speeds up your feedback cycles a lot. So specifying like this, and also configuring your test container properties to enable reuse, now allowed.
We don't have.
Wait! Don't. Okay, all good.
Yeah. I know.
Right. So we reuse. Let's come back to this. Never show your configuration files on stream without.
Yeah, but I checked
thinking
them
about
first.
that.
Yeah, you never know what could be.
So
yeah, but I checked.
Just back to the flow of the stream. We are now reusing this container. We're saying that this container should outlive the JVM process, and we are configuring that both on the container level and on the machine environment level, right, in your user properties. And with the combination of both, now this container will not stop after our tests are done, but then when we run the tests again, they will use the same container instance, right?
Exactly.
It will do like a little bit of magical mapping, and then determine that we already started this container, and then because it's specified with reuse, we can use it again. Very good.
But if you don't believe me, I could.
No, I believe
drop
you.
the data, but I do not want to do it now.
No.
Yes,
we believe you. We believe you. We're just explaining so everyone believes you, right? So
yes.
And as you've shown with printing out this URL, that this also gives you a way to expose this interactive Neo4j console. So yes, you could open it in the browser and do even more explorative stuff.
Exactly.
So that's great.
So, for example, if you really want to, I just need to cheat right now. If you really want to get more explorative, then you can start with this console/browser and really say, I just want to peek into my domains. What creatures do I have? Do I have something like for example, let's be, so every creature is a Pokemon right now. That's why I can shorten this. We have seen this, maybe. Oh, of course. Now I find my my Pikachu or my Pichu, and then I can explore from here what's connected to this. Like every card, for example, that's a Pichu card, and similar things. So this is interesting, just to get this explorative idea in there. I could also
And
say
what was also cool, yeah.
Because I've seen this. So Kevin, please.
I wanted to say what is cool about this. Like, of course, we could run it with Docker command line or whatever, but we were even able to just have Java code now to set up an explorative environment or whatever. That's quite nice. Yeah.
Exactly. And the very same applies now to the explorative. What I said, when I was exploring this, I've learned that there used to be a type of Pokemon that do no longer exist as cards. But so I was interested. This was fairies that got psychic types, and you can see by its very nature from the query language. Excuse me. Yeah, maybe this is better. That we can via the ASCII art really formulate our queries. Yeah, I want to find all cards, and now I have to do the cross product. Because I want to match every card with every other card. So there's no way around this. And I want to find those, for example, those cards that are from type fairy, but also from the type psychic. Not the very same cards, but different cards that point to the same Pokemons. Now I have this type, and now I know which ones are the Pokemons, for example, who used to be fairies and now psychics. Just this play around, just this explorative journey through the graph is, I think, very interesting, because I when I did this whole importing thing, I read some rules and then said, okay, I need to verify this via the database. And so you can see that at least from the naming, 28 Pokemons used to be fairies, are now psychics. Yeah, that's totally interesting. Yes, coming back to the code, because as I said, I could nerd out on this topic already hours.
It seems so, yes.
What we wanted them to do is to create another test, because there's also one interesting feature. So we have super rare Pokemons. Super rare is a special type of Pokemons. As I said, when I spoke about the imports, these sets have this total numbers of cards. But also the card import itself for a certain set says this is the number of this card. And there's this trick. So super rare Pokemons are those Pokemons who are out of bounds now. So you have, for example, a card with number 201, but the set only says it has 200 cards. And so this got me interested also. And this is the example where I want to show you Spring Data Neo4j for a second. And we do this now on a very basic level without any more relationships, etc. So that you get the idea. So also to get even faster, I use now Spring Java 17 records. I say my ID is the card ID. The card has a certain name on it, and that's for now everything. We can see if we have time, if Oleg allows us to do something more, that we also add relationships to this. But for a card, that's now my domain. I create, and you have seen this for JPA last week, a repository like in the good old Spring Data fashion. So I do not really have to explain a lot about Spring Data Neo4j. If you know Spring Data, it's the same pattern. So you define those interfaces to access your data, the repositories. In this case, either the Spring Data-based quad repository or the Neo4j typed one, Neo4j repository, where there's a card with the identifier type of string. And then I can just go ahead and, for example, just keep it as simple as it is right now. I have the card repository. I have this test here. We do not. Yeah.
So the repository itself would come with the normal like sort of CRUD operations, right? Because the repository does that.
Exactly.
So you can fetch all cards, for example, or just normal things, right?
Yeah. So we have this built-in CRUD methods already, finding, deleting, persistence. Everything is built in. So also a little bit more like you'll see this find by example things, etc. But you can also issue custom cipher with this. Sometimes you do not want to model your whole domain in your Spring Data Neo4j application. That's a little bit different from what we have seen at customers or users. In contrast to relational databases, is that Neo4j instances get more in this shared use mode, where several applications access the data or write data to the database. And so you do not really, when you look at the database, want to reflect every property, every relationship that you see in the graph. When you when your domain, or if your domain in your application do not need this. For example, what we do here is, first of all, we just hijack the code I've written already.
So maybe let's start before we add the code. Let's start with the like this most stupid implementation that would then fail. So maybe the could you write something that does, I don't know, like find first or something like this? I don't know, like something.
Find all.
No. I was thinking we start with the actual method we want to implement, like TDD style.
Okay, yeah, but the problem is that here that I use custom cipher, so I can write whatever is not matching. So, for example, I use the wrong relationship here.
Okay, for example.
So I have a bad relationship name in there.
Okay. And then we already use our existing business domain knowledge that because we know, okay, obviously Dark Raichu is a super rare card, but EV not.
Yeah, exactly. That's what I want to explain. When I explored the dataset, I found out, for example, there are some names that have the super rare rarity, and some who never have this. So there's non-card with every on this, although every is a very popular Pokemon, and that is super rare. So this is the thing we want to find, but we know that Dark Raichu is in there, in those lists. But for this, we have to follow some relationships. So we're looking for certain cards with a certain rarity that are part of a set. And now we want to make sure that they are not only, rare secret, sorry, not secret, rare. Terminology, I have to learn this all. Where we want to be sure that the card number is higher than the set number. There are some, of course, there's always an exception to the rule where this does not apply. So I really wanted to have all these relationships mapped out here and just get the cards back. So you see, I use custom cipher because I do not want to model this rarity. I do not want to model the set. At least right now, I do not want to model this. I just want to have this card, and I want to get this card returned in the end. Yes, and the rarity has rarity, the rarity relationship. Now we call it the rarity 2, so it shouldn't find anything. I enforce the before each, so the init DB would get called. So we have this check up front. And we should now see that it fails. Great.
Right. Our test fails.
Our test fails because dark Rachel could not be found.
Yes, because we mangled the relationship name, right?
Exactly, because we were following the wrong relationship. It could exist. There's no schema. There's no schema in Neo4j. So you could probably have this on some cards and rarities. You do not have to have this.
This is actually what the sentiment in chat was as well, that making it work, that this schemaless database engine, and then it works nicely with this class-based depiction of the instances in the Java world. That is not an easy engineering feat. That took some work to figure out, and yeah, I think it's pretty brilliant that this works just like that.
And and it makes fun if it works. Not this application itself, but this whole mapping thing, etc. And you can see we have now a green test after I fixed the relationship for this.
Right. How long was the test? Like, can you? I don't see the number.
Yeah, I cannot increase the font here. It's around about 400 milliseconds.
Oh, so very quick.
So we reuse the machine, etc.
Nice.
So it's starting the Spring context, but then the actual interactions very fast. Yeah, cool.
Yes. Yeah. I don't know how much I will burn if I say, okay, now you see it's not Testcontainers Springs, it's slow. And
I could imagine. So I'm a noob in Neo4j. I'm a noob with the Cypher stuff and so on. So if I would get started doing trying to write a query that works, I would probably work like this. I would hack around in this query until I have a working test. So this would really nicely support my kind of TDD feedback workflows.
Yeah, of course. Or you could use, of course, something like the built-in methods we have. We have this pattern in Spring Data in general, where you say, okay, find, by, and then you use a property that you have defined on your class, on your domain class, like name. And you put in something like, so my parameter will be name. Do I have to use this? No, of course not. Sorry for this. And I could call it whatever I want. And this will create a Cypher statement already for you, because we have those users who love to use Spring Data Neo4j because they do not want to write Cypher. They do not want to collect the whole data and then map it by hand. That's also a type of person that we have in our user base. And that's not wrong. I think that's also a good entry if you just want to have a graph database, but you have no experience. And in the first one, the generated Cypher statements are satisfying for you. Why don't you use it when you know Spring Data patterns like this one? Where we create the query, where we create the right return pattern that we can match as much as we can. Because when you change the domain, you also have to take care that you return the right data. Yeah. For example, if I want to return the set here, you add, for example, the relationship to a set here. Is part of, I think, was. We don't have to execute it, but you can, for example, we have then this card set like this. So I do not want to write set because set in Java is somehow burnt word. As a type, we will create also the fetching for the set for you if you fetch the card with this method. You do not have to take care about the return pattern. We just add this. And if you would have this manual created query, then you would have to do something like this. Of course, and even more, because relationship to set. Okay, that's. I just want to be unambitious here, because you have to name them those things. In the end, we are very strict when it comes to mapping in SDN or Spring Data Neo4j. We only map. We wouldn't look into this return set and say, okay, there were some Pokémon cards and there were some sets. Maybe we can combine them. We need to be sure that there's also this relationship between them. We cannot just connect data in the Java object model. if you do not have the explicit relationship also return. So you can see that this return clause can get very, very broad in the end. We can match everything if we have the information, but hey, if you want to try, if it's okay and sufficient, please trust us in Cypher Query.
Oh yeah, I would always prefer trusting you than trusting myself. So
yeah,
because sounds like a good deal.
Hey, people,
this is very, very important.
People who write those
realize...
statements can only be a good Cypher statement creator.
My take on that, personal take of that, is that when you see an issue, a bug, right, it is never a compiler bug, right? It is very rare that you hit issues in the underlying technologies. So I would prefer not to write code, well, as minimum code as possible. So Spring Data Neo4j would fit my bill. And there was a very nice comment there in the chat by Michael. Thank you, Michael, for watching us and providing your point of view that the combination of using test containers with the reusable mode is fast enough to do test-driven development very, very nicely, right? Because there is literally almost no overhead, right? Especially if you use some sort of a reloading technique like a Spring DevTools or the dev mode in Quarkus, or just your application starts really fast by itself, then the environment just stays there for you.
Yeah. So you could
that's
also
very cool to hear.
Also start during your integration time. I just jump over to another application where I tried those things out. You could also, for your integration time, create this application starter, this foreign application starter by the pattern Kevin was keen to give me. And I think it's linked somewhere, right? Kevin, I don't know.
Yes. So there's a great blog post by Sergey where he explains it in a lot of detail and also different flavors of it. I think it's So we will link it in the show notes. I think.
Yeah. And if you're referring to the very same container, and this very same container has this reuse flag on, and you have also configured it via your local variables, then you could work with this. I don't know how much time is left, because I really, really want to show, because it blew my mind when I've seen this, the test container cloud support for this. It was amazing, because I never thought that this could work. So
okay,
I'm just
we are short on time, but I'll allow it.
Okay, thanks. I'm just starting the test container cloud integration with our newly created application. And I have now this integration test, and we all hope that the reuse does not get fired right now.
Right. So just to elaborate what you did, you started the Testcontainers Cloud desktop application, which is the client, which when you run the tests next time, the test containers Java library will determine that you're running with the Testcontainers Cloud client enabled, and then it will use the software as a service environment for you to run your Docker containers instead of running them locally on your machine, right? So you kind of separate that, and
what you have not seen, is that what I've not done. I haven't changed anything in my application, so I still have the very same containers definition, etc. So it's just a redirection from the local connection.
Right, and you run this test now, and the Testcontainers Cloud created a fresh environment for you, downloaded the Neo4j Docker image, started the container, and did the import and everything for you, and it now runs there somewhere in the cloud.
Yes, exactly.
So as Gerrit said, like the initial import takes like 40 seconds or something. So that's what we see right now in the fresh container. The import on the first before each happening, I think. Yeah.
Even though that it was the best with Cypher I've ever did, it might have be optimization potential.
While we're looking at this, can you just, and this is just what I'm personally interested in. So you run your Neo4j containers locally before this, right? Do you configure Docker resource usage somehow, or do you just use default there, or Because
I
I've seen
just set this. Sorry.
I've seen sometimes people give more resources to the local Docker instances to speed up the behavior of the applications in containers.
No,
Gerrit is
I'm
on
running
Linux.
so
Yeah.
Oh yeah, so on the Linux it is just using all the resources you have. Nice.
yeah. So
If you're not on Linux and watching this, then you might want to review how much resources Docker has access to. So
yeah. So you can see now it was 50 seconds. Maybe
okay,
because
that was
things,
the imprint.
but it's a
Run
ballpark
it
of
again.
40 seconds.
Yes.
We have a request to run it again.
By the audience.
But I don't know what you're expecting. It will 1 minute or something. No. Hopefully, we can see that. Oh, 600 milliseconds. So the very same applies to Test Container Clouds. And yeah, it's the very same. It's not only the reusable thing. Oh, yeah. I'm not a developer advocate at Atomic Jar, but I'm really impressed by this. I also have now this clickable link again, and it will redirect me to my running instance in the cloud. So I can connect to this. Yeah. And I'm now connected. It looks very same, but you can see that the colors will just shine in after the first click. Now it's a machine that's running on Testcontainers Clouds. So I have also the possibility when I start now my development of my application. And I started, okay, I need to change this to the other application. And I really start the application this way. I can have my tests and my running applications use the same database. I can also, I don't know, use it a few minutes later, and I have the same data in there. I can use it for continuous integration builds, etc. So that's what I don't know if I've answered this upfront yet. We are using SDN test containers to an extent where we also introduce it in the latest builds for Neo4j OGM, our parallel, a little bit older mapping library, because we have seen the benefits. And when you ask us for checking out Testcontainers Cloud, we threw it at our medium-sized applications, so that Michael create. And we also used it for example, our Neo4j object graph mapper builds. We're just working flawless. So we've read the short documentation. Everything is running. So we should we did not need to alter anything, and that's great.
That's awesome feedback. Thank you for sharing this. This is really great to hear. Right.
So and that's what I wanted to show. If you have any questions, go ahead.
So maybe as a final thing, let's maybe look at the running application, like how we would just start it from the normal application class, Spring Boot application class. And yeah, let's just go ahead and just for the fun of it, configure our normal main application properties to just use the Neo4j instance running in Testcontainers Cloud now.
Yeah.
Just to see that this is also possible, and that we can.
We really use this application now. I copy the bold connection. That's the pure database connection. So the first part is the console browser URL, and then I can pre-populate the connection with this. And I haven't lied. So there's nothing right now in my application properties. I spin my Spring Data, my classic Spring Data setup, connect to the Test Container Clouds instance, but I do not have a application right now. I do not want to create web pages right now, so I just implement the command line runner that should then connect via the repository.
While you're typing that out, there was a very nice comment by Michael again there. Let me just put it back on screen and read it. Right, with respect to Spring Data Neo4j and Test Containers, after we, and Michael works for Neo4j, after we created the Neo4j specific container in the first place, we're using it ever since, and it's also used widely by our field team. So Neo4j, yeah, this is thank you, Michael, for this great testament to test containers and validating the developer experience is really something that makes different teams want to use it and that you see value in it. Thanks,
And
Michael.
of course, thanks a lot for contributing the Neo4j container in the first place. So it's a great addition to our modules.
Yes, and it got the latest updates for this version.
True.
Yeah. Yay.
Right. So
yes, what I did was injecting the repository that we've created before into my application, and just after the start, I want to print out the alternate cards. So if we connect to this very same instance that I've promised via altering the one parameters.
So this is how you would normally configure your Spring application to work with the external Neo4j, right? You would use the application properties to configure where your Neo4j database is running, and this is exactly what we're doing here. Instead of like having this managed instance somewhere in the cloud or managed instance somewhere in our data center, we're just using the URL to the instance started by test containers when running tests.
Exactly. So, and this is independent of Spring Data Neo4j. It's just if you put a Neo4j Java driver on the class path in a Spring Boot application, the Spring Boot auto configuration will look for those properties and even more, of course. Those are the basic ones, and connect to the or give you a pre-configured instance of the driver that then can connect to the database. Yeah. And so I'm just starting the application right now. It won't stop because the plan was to also have some web there. I don't know. Oh,
many cards. Cool.
Yeah, I did not print out the count, but I printed out all 14,000 cards.
Yes, I'm happy about this.
So
it was very fast. I thought maybe find all is super slow, but it's super fast. Cool.
No, there are a few tweaks in Neo4j that make it super fast. Like, of course, indexing is a more general feature, but we cache labels. So when I ask for every card, it does know which bit in your memory are cards, and then returns.
Oh, that sounds excellent. That sounds really cool. Yeah.
So if you do not want to nerd out on Pokémon, there's I think a paper or at least a short essay about the memory structure of Neo4j databases somewhere. Then you know how we follow and we chase the relationships.
Excellent. And then, yeah, this is cool. So now you can develop this application if you would like further, add the web UI to it, showing data, add more queries, write more tests to this data. And in general, I think we've shown that the system is working and all the components, Spring Boot, Neo4j, test containers, all integrate together in a very smooth fashion, right? I don't think we configured anything much. It was very, very straightforward to get started.
Yes, and this is
explore the data.
I would say that's great for mixing test containers with the dynamic property sources given by Spring Boot, and of course putting Neo4j to the mix.
Right.
And Pokémon, of course.
And this is but I think this is how you should even have fun with non-such funny domains. Yes. Neo4j is also not only known for investigative journalism, but also for medicine, for banks, etc. So money laundering, etc. So there's a more serious, detecting money laundering. But those are those serious domains. But if you have the right technology at hand or the right technologies, they are not in your way, or they should not be in your way when you develop business functionality. They should help you. And yes, this is a play, for example, with Pokémon, of course. But you have seen that we talked. I could talk a lot about Pokémon, but have in the end a running application and combine those technologies. And it can expose the data.
Just to sum up, thank you, Gerrit, for this excellent stream and this great example. I think we all had fun with the Pocket Monsters. And
I hope you did.
So what we did, like, just to recap what we did, right? We started with an empty Spring Boot app, and we added the Neo4j database connection to there. We started writing tests with test containers. That was very straightforward. Then we implemented the reuse mode of the tests on the containers, which made our initialization logic run only once. So our tests were much faster. Then we explored the data in the Neo4j console, and I love that bit. I love great visualizations. I am personally very horrible at making things pretty, so but I have a soft spot in my heart for pretty things that other people made, right? And yeah, so we did that. We explored the data a little bit, and then we wrote tests for that, and then we integrated the Spring Data Neo4j plugin, right? Module, how do you call it? Dependency. Well, we integrate the Spring Data Neo4j and run queries through that, both fetching data with custom queries and using the predefined find all, find by name, find by properties things. I think that there is I can only imagine how much work went into mapping something as fluid and schemaless as a graph into the class schema. And well, luckily we didn't hit any errors there, any issues, because our class model was kind of simplistic. But the type system would be helpful guide to make things work. And then we used the Spring application, and they deployed it sort of, right? We configured it to use an external Neo4j instance as you would normally do when running your Spring application. And it all worked on the first try, which is very, very great. So
yeah, I haven't expected other, but of course not. We are all engineers, and we know that we don't fail on the first try. But I just wanted to add to the mix that we have seen in SDN, of course, not this very powerful feature of graph databases right now with relationships, and that's also something I want to point out, that this is, of course, something we put more focus on, that you can also define your relationships well enough and with a fine detail grain. But yeah, if you want to know about more about Neo4j, SDN, etc., ping us, ping Michael, ping me, Twitter. We have a community. I can send you some links, I think, Mike, that we add to the live stream, or like what?
To the show notes. That's
Show
what people
notes.
always say.
Yeah.
Yeah,
And
great.
if you want to ask more questions towards any one of us, specifically to Gerrit, you can find him on Twitter. He goes by Meister Meier.
Yeah,
Meister Meier.
I cannot write anywhere, so
Yeah, we'll link the socials in there. And thank you very much for being with us. And this was a very educational episode. We learned about Pokemon. We learned about types and the system Neo4j, Spring, and I think it was very, very good. Thank you, Gerrit, for spending time with us. Thank you, Kevin,
Thank you
for
again
helping
for the
us
invite.
hosting this. And we're gonna see you next time. We have an exciting guest next week. There are no links yet, but we'll figure it out. So subscribe to the channel, get the notifications on, and we'll see you then. Until then, happy hacking.
Bye-bye. Have fun.